an artist's conception of the most distant supermassive black hole ever discovered, which is part of a quasar from just 690 million years after the Big Bang. Robin Dean Carnegie Institution for Science Eduardo Barnardos had 3 nights to spot something that might not even exist, a supermassive black hole close to the beginning of time. At the Las Campinas Observatory in Chile, perched high atop a mountain in the world's driest desert, he scanned for the signature of a massive, invisible sinkhole in the sky slurping up a whirlpool of brilliant, hot matter. Just before sunrise on the 3rd night, he found it. Way out at the very edge of the observable universe, there loomed a black hole, 800 million times more massive than the Sun. The signal had traveled more than 13 billion light-years across time and space to reach Barnardos telescope. In a paper, published in the journal Nature Wednesday, Barnardos and his colleagues report that their new find is the oldest and most distant black hole ever discovered. The object's size is stunning, Barnardos said, because it existed just 690 million years after the Big Bang, when the universe was just 5% of its current age and still emerging from an enigmatic era known as the Dark Ages. That such a large black hole can exist so early in time will shape models of how black holes form. And it will offer insight into the universe's hard-to-study early years. If the universe was a 50-year-old person, Barnardos explained. Now we have a photograph of that person as a toddler. When they were 2.5. The Dark Ages began just a few 100,000 years after the Big Bang, once the hot particle slurry that constituted the early universe condensed into atoms. The universe was getting bigger and colder in this period, filling up with a featureless fog of hydrogen gas. There were no galaxies, stars or supernovas which appear when stars explode, nothing that gave off light. The only form of radiation was a very weak hydrogen glow. This state of affairs lasted for hundreds of millions of years. Yet sometime during this inscrutable period, the universe as we know it emerged. Gravity pulled hydrogen into the first gas cloud, from which the first stars were born. The radiation from the newly formed objects broke hydrogen atoms apart into their constituent particles, protons and electrons, finally dispelling the chilly fog. This process, called reionization, because previously neutral hydrogen atoms became ions with an electric charge, was the last major transition in the universe's history. Understanding the reionization epoch, Barnardos said, is one of the frontiers of astrophysics. The absence of light sources during the Dark Ages makes it difficult to probe this period with telescopes. The hydrogen fog further complicates matters. Barnardos says it is as though someone went through the universe's childhood photo album and ripped out all the pictures of its most formative years. But studying the behavior of the universe's very first quasars, luminous whirlpools of fast-moving, ultra-high particles surrounding supermassive black holes at the centers of galaxies, could shed some light on this inscrutable era. That hope is what drove Barnardos, an astronomer at the Carnegie Observatories in California, to the Chilean mountaintop in March. It was not entirely clear whether he'd be able to find a quasar so far away. Supermassive black holes swallow up huge amounts of matter, squeezing the equivalent mass of several 100,000 suns into a space so small that gravity wraps around it like an invisibility cloak, and causes it to vanish. An object like that needs a long time to grow and more matter than might have been available in the young universe. But the object Barnardos and his colleagues discovered, called ULAS J13420928, was even bigger than they'd bargained for, suggesting that something might have made black holes grow more quickly. Scientists don't yet know the underlying reasons for such rapid growth, or whether still older black holes are waiting to be found. This is what we are trying to push forward, Barnardos said. At some point these shouldn't exist. When is that point? We still don't know. In a companion paper, published in the astrophysical journal Letters, the scientists report another odd finding: the where ULAS J13420928 dwells was generating new stars, like crazy. Barnardos said. Objects the size of our Sun were emerging 100 times as frequently as they do in our own today. To build stars you need dust. Barnardos said. But it's really hard to form all this dust in such little time on cosmic scales. That requires some generations of supernovae to explode. During the universe's toddler years, there hadn't been time for several rounds of stars living and dying. So where were the ingredients for all these new stars coming from? Observations of the light coming from the quasar point to a third curiosity: this object lived when roughly half the universe's hydrogen was still neutral. That places it right smack dab in the middle of the reionization epoch, when the light of the first celestial objects burned away the Dark Ages fog. Maybe we are probing the region now where the first stars and galaxies formed, Barnardos said. The quasar is basically a goldmine for follow-up studies of this 2.5-year-old universe. Read more. Gravitational wave from black hole collision 1.8 billion light-years away sensed in US and Italy. This black hole is being pushed around it by gravitational waves. What does a black hole look like? Astronomers are on a quest to find out.